Awesome. Awesome. Thank you. Yes. So how many team members we have so far? Okay. So we got it. Oh, Jillian is here. Awesome. So first, let's do a little bit configurations, because too much theory is not good for health, right? We need to do some kind of lab also. So last week, if you remember, we did a Docker, and some of the topic we Docker, it's kind of, we have to repeat as we go further because it's kind of connected together. But let's complete that, making sure our computer is working fine. So the theoretical perspective, we need only one software, which is called Docker Desktop, right? Windows Docker Desktop. And that we have installed last week, if you remember. We have installed Docker Desktop. We went to the features, Windows features, and in Windows features, we enable hypervisor. We enable hypervisor, and then we install Docker Desktop. So if you have installed Docker Desktop, great. If not, I also repeated here that you need a couple of software. So we'll make sure our setup is there. So here I put it here somewhere, maybe later, that you need to install. Somewhere I have done mention here. You will see somewhere I have mentioned that you need a Docker install. Here. Sometimes, I'm copying and the refresh is causing trouble. Maybe I'm not have refreshed or what. But anyway, Docker Desktop things is also in the Google class, in agenda also. I put in an agenda also. So in case if you have received agenda, PowerPoint, Google class, whichever it is, only two things. If you have not installed, I would strongly suggest you can install, because you can get maximum value here. So last week when we say, you know what, install that. So you will assign to create a Docker account, and this one that has asked create a Docker account, do that. And here in my agenda also, I kind of give the same thing. Hey, make sure you complete installation. And this is the installation part. So if you have completed, great. If not, you should do it. I have Docker Desktop installed. Again, installation doesn't take too much time, but make sure you have it, because trust me, if you are going for DevOps, Docker and Kubernetes is essential part of that. So we are going to use Docker Desktop. There are a couple of ways you can learn the Kubernetes. One, you can learn through another software available called Minikube. You can do that, Minikube, and you can do. But because we have Docker Desktop install, I'm using Docker Desktop. So let's go to start the Docker Desktop if you have it. If not, you can start that. I think I have it, but let me right click
Quick
and.
question.
Yes, sir.
We have Cloudera virtual machine in big data.
Yeah, that is nothing to do with this one.
No. My question is, there can in Cloudera can we install Docker?
You can. Yeah, you can install Windows or Linux, any machine you can install. It is not that complex. Installation is not that complex. You can install in an EC2 also, and you will have a lab how to install. I'm going to show you. You will install part of this class. It won't take long time. You just need
Cloudera image is pretty old.
No, I understand, but it doesn't matter. It just we are looking for Linux CentOS. But as long as you're CentOS, you are fine. We are not really using Cloudera as such. We are using Linux, right? So if you're Linux environment, you can upgrade the Linux environment and you can install. So should not be a problem. We will do EC2 through, because lab I created through EC2. So you will do through EC2. Next week we'll do that. So right now I'm going to start the Docker Desktop. So when you start the Docker Desktop, you will get a, what do you call, visual kind of easy language, like, some kind of dialog box where you will see the options called Docker, and you will have option called Kubernetes enable. So when it comes, I'll show you. So right now I'm starting that, and I already steps I have added in a forum. So let it start. Meantime, I can show you the forum. So here, as you can see here, when I start my Docker, it gives me option that you can go to setting, go to Kubernetes, enable that. So I'm gonna do that. So you can see here, this is the dashboard I have. Now you can see here the options is setting the gear. So if you click on the gear, right? If you click on this gear, once you start, there is options available. Kubernetes. This is your container runtime. Docker engine is already there, Kubernetes. So if you click on Kubernetes, you have to check this both. Check this both. It may take a while. It takes a few minutes. So just check. And after that, it will ask you some questions. If it, just follow the flow. Sometimes it takes a minute or sometimes it takes 10+ minutes also. So just complete that and it will install the Kubernetes for you. And when it installs, you see green color. See, it's done for me. It's done. I have green color because I have already did. But if you get a yellow color, sorry, orange color or red, it means it failed. Try to read why it failed. So it can fail in many reasons. If it fails, you may want to restart and try one more time. It does work. But it worked for me. I'm sure it will work for you as well because it is not using any special thing. It is just using Docker runtime, right? And it deploys container in that. So it right now what happened when it starts, it used the what do you call our Kubernetes control plane container in Docker. And once the container starts, it gives you green signal. Let me know if you are able to check and start. Remember, it's in a Kubernetes. You went through the gear icon, again Kubernetes, and from there you check and just wait for a few minutes and you will see green arrow.
Yeah, it's starting.
Yeah. Today, by the way, I ordered 2 desktop because it was a good thing. One I got, just want to show you in case if you don't believe, I'm a big fan of Amazon used computer. It's $149, 32 GB RAM with i7 and it has all goodies. So I thought maybe it would be good to teach this class because you see my almost it using all my memory. In this computer, I have 4 GB. And it
Okay,
using
what generation is it?
i7.
i7, generation 7, 8, 10.
Yeah, it's the 7th generation I have. But comparatively, what this one I'm using is i5. This is i7. This one has a 4 GB. This is 32 GB. And it has a 1 terabyte SSD. So at least I can teach this class more effectively. So I just set it up. Hopefully by next week it will be ready. I also bought for Office. So Cloudera I can install and run faster because it's slow.
Is it also from Dell?
Dell. I only buy Dell. Yeah, because it's reliable. It works. It just works.
I mean, after you said I tried to find the used one on Amazon, I couldn't find it.
You have to find. I normally find easily, but let me see if I have. Let me know if your Docker is running so we can go forward. But meantime, I bought this one. It's 149. One is 249. So I just got that. You cannot beat that price technically. My order.
Of course.
Minimize. Let me go to order.
Are you talking about the used or recertified?
Used. I buy used, only used, but they give you 30 days guarantee. Or normally Amazon, these are. So you can see i7, 32 GB. Another one I bought is i7, 30 GB. Good enough for me, for my lab, because I need more memory. Right now my machines are struggling. Okay. Are you guys able to start?
Yeah, mine is done. It's
okay,
green.
Perfect. Okay, perfect. Anyone else is able to do? Mike,
mine is still, it is working on it.
Okay, good. Parth, what about you? Still installing, good.
Mine is yellow and it says enable Kubernetes starting. It keep going like that.
Yeah, it will take quite a good time. It will take quite a good time. So while you're doing that, I'm going to give you a couple of minutes overview and then I have theory to cover. So once it gives you green light, right? You go to CMD and in CMD, you just type this command called kubectl and press enter. If that command recognize it means you have installed Kubernetes. Okay, I would say congratulations.
Yep.
If you install that, and then if you do version, right, Kubernetes version, you can see the version you are using is 28.2. Good. While you are installing that, those who are installing, some of the Kubernetes commands are Linux commands, and it's pretty hard to convert into Windows. I tried a lot. So I found a solution. I found a solution because in my work, I use only Linux, but here we are using Windows. So I found a solution that we can install on our Windows, just like you're installing Windows Docker desktop, you install Git Bash. As per my knowledge, you already studied Git, so you might have Git Bash client for Windows. Git Bash client. If you're Git Bash client, then Git Bash clients gives you Linux environment. So I have it, but in case if you do not have it, I can say you can just search here Git Bash like this, Git Windows client like this, and then you will get that. So you can install this one. I install Windows, but you can install whatever you like. Let me put it in a chat. You do need that. I'm sure you might have because you already have covered the Git class. Very useful. There is a trick. No one will tell you, but this is a trick. You don't need to install Linux. It will work. Most of the command will work. To copy the link, let me know if you are able to see that, and then let me put it in a chat so you can have that link. And some reason it just disconnected. Okay. Now I'm hoping you have, if not, just download that Windows client. I have it, so I'm going to start it. So if you start bash, and you can get Git Bash, which is kind of Linux flavor. Most of the command which we are going to use will work in Windows and Linux, but there are certain tips which we are using in Linux, which can be used in Git Bash, and I can use both at the same time. So I click on Git Bash, right? Click on Git Bash, and it's a pretty tiny software, but very useful. You may need that for next week homework because you have to clone some of the repository. Now here also I can say kubectl, and you should be, spelling is wrong, kubectl, and it should be able to, you can run it. Good so far?
How do I go to command prompt?
CMD.
I am not getting that setc.
CMD.
No, how do I get this setc command? This one, yeah.
I'm
I
not
don't
sure
have
how. You should do Control R, I believe. Control R or Windows R, I believe.
Windows R.
Windows R, right? Yeah, and then you can search it. If you don't have it, then I don't know how you can search.
Or you have to enable it from the taskbar settings.
From where?
If you right click on your taskbar,
Mm-hmm.
you will have a setting option. Just go there and enable the search bar.
Like this, right click. Yeah, my machine is quite of slow, so I'm not going to do a lot of activity right now. Let me just quickly show you here. So I have Windows and I have Linux. Both are up and running. So this is my Windows Git Bash client, and this is my thing. Now, in the real world, you can use either one. Doesn't matter. Most people use Linux one, so that's why people use this one, because most people have Git and they're very familiar with the Linux command, so people use it. Now, let me go back to my PowerPoint. There are a few more things I need to cover before we do further activity. Now, at this moment, at least I'm counting your Kubernetes cluster would be up and running. Give me thumbs up, right? Awesome.
Yes, working.
Awesome. So now let's understand a few commands. So you can see here, we are getting a prompt. Now write down this command kubectl get, and then any resource you want. So we are doing get nodes. Okay. So let's go here. I'm going to use Linux one because that's my way. So I'm going to say kube CTL cuttle, and then you can say whatever your resource you want. So here get nodes. So right now by default it will have one node for you, which is called control plane node that Docker desktop. So I say kubectl get, this is the resource. So you can see that this node name is this, and this is the control plane application. So what happened is when you started Kubernetes, it use a container, and container always run a pod, and it pod runs under machine. So you have that information. So right now I'm saying, hey, show me nodes. So node means this machine. So machine name is right now Docker desktop. Now I'm going to say, hey, show me pod, and then show me other things. So here I use up arrow. Instead of node, you can say pods. So you can see here, so pod. You can no such found. So right now it's not no such resources available in default namespace. So right now it's a default namespace. No. So I'll say, do I have namespace here? Right? Namespaces. So I have this many namespace. Let me know if you are able to see any namespaces. I think you should see that because by default, this one, and this one is always there. Yes or no?
Yes.
Got it.
Yeah. And this is the lease is nothing but like, very similar as associate type of thing. It kind of keep it as a sidecar. There is a sidecar available. Now, when we are going for administration time, you are going to use always kubectl command. But if you are going for EC2, the command will change, and it say elastic a key kubectl like that, something different command, but that command actually does the same thing. They will write this command, get parts, get. So there is a one thing called a thing. There is a confusion, but making sure let's understand. So what is the thing means? So pod is a thing that sometimes people say pod is a thing. So what does that mean? So what happened in a container world? You cannot log into the container, but because pod is a thing, you can log into pod. So sometimes people ask, can I log into pod? Answer is yes, you can log into pod. So pod is a thing, just like a machine, just like a VM, pod is a thing, you can log into that. But container, we don't log in. So container, you cannot log in. You can enable SSH prompt by execute command, you can do that, but you're not able to log in. But pod, you can log in. So we can see that. Second thing, anything you see here, like a namespace and all those are command through, we can see most of the command you can see. There is another thing called Kubernetes dashboard application, which we'll cover next class. We can install and we can see the same admin through GUI, and I'll show you that as well. So right now, I would say congratulations, your machine is well set up, and don't disturb that. So one more time, any request comes, it always go to your Kubernetes API proxy. It always go. Now this proxy is the one who is asking main controller what should do. etcd is used for the storage purpose, right? Scheduler is used for start node, start pod, start container. So timing wise, schedule is when to start, when to stop, like that. And we talk about control manager. So these are happen. Node is always a machine, and one node can have many pod, and one pod can have many containers. So those are the relationship. We discuss about in a great detail that anytime you start your cluster will always have two things. One is a control plane and one is the node. So control plane where you do master activity, and node means you have this activity, right? So control plane is the one which we need to understand. So master Kubernetes is always interacted through API or kubectl, and container are always running on a worker node. So this is the area where containers will be running under pod. Now, as you go further, I have a small video. I would strongly suggest this video you should watch a couple of times, so at least you understand the concept. Whatever concept I explain, it's explained the same detail here as well. This is our video. Now we discuss about already this, but just worth repeating. Anything come here, this is the distributed. We talk about multiple database it's used. So HCD is a distributed, high performing key value database. Distributed means multiple machine, high performing key value database. API server is the point of entry. Control manager is the big guy who manages the control. There are many controllers out there, and scheduler is nothing but when to start, when to stop, like that. And every time you interact with the kube proxy is nothing but getting the traffic and directing the traffic to pod. So kube proxy get the traffic from outside world, pass to that. Kubelet is the one who enable your container and pod. So kubelet is the container and pod controller. So it does that. And every machine will have these agents running. Now, as you go further, we talk about master maintain desired status. So here is the very interesting thing. Listen carefully. So if Viral says, I need this container 4 copy. So master say, okay, let me write down in etcd. So master will write down in etcd Viral request. And then master will send to controller. Controller, do it for me. And controller will work with necessary kubelet and all and get you the desired copy. So he will have a 4 copy running. Then we'll all say that, no, I need now 6 copy. So what when say 6 copy, it will go to master. Master will say, wait a minute, etcd say 4. So it means he already have 4, he need 2. So let's do 2 more. So he has that. Then he said, no, I need 3. So it will go back to master. Master say, oh, it's etcd says that you have 6, you need 3. So they will give control, stop this and get you 3. So what master does is whatever you request, master try to fulfill that request. If master cannot fulfill, you get error, but master normally maintain the current state and receive the desired state. So customer sends desired state, customer send request desire. etcd maintain the current state. If there is a delta, then Kubernetes will adjust it. So let's say you requested 4, master got that and master maintained etcd 4. So in etcd, master mentioned 4. Now 4 containers are running. Some reason, something happened to one container. Then master will say, oh, master will get notification. Oh, there are 3. etcd is 4. So desired state and current state supposed to be 4. But desired state is 4. Current state is 3. Master will create a new container for you. So master will automatically schedule those things. So that is the reason master use scheduler to make sure it does the things for you. Okay. Controller is nothing but replication, which we talk about. How many replication? So there are 2 words I want you to understand. Sometimes we call replica. Sometimes we use word scale. They're kind of same word, scale and replica. So when you say 4, it's a scale. I want 4. Replica is there. So replica perspective, anytime you replica, your request will be scheduled first, and then controller will make sure it does. And all the data for request and status will be maintained in etcd. So etcd does data storage part. Now we talk about in a detail. So API server is a forward REST. We talk about all clients, another application goes through the API. So this is the point of entry. Make sure you remember that. etcd we talk about is a cluster data stores, nothing to explain there. Scheduler is all about when to start, when to stop kind of thing. So you can provide the information when to run, when not to assign. So you schedule a job, basically. You don't get instantly, you schedule a job. Again, factor taking the resource and requirement and hardware based on hardware, it does that. Cloud control, which is go through many controllers. So this is the master controller. Master controller has a sub controller, node controller, manage the node. Route control, manage the route. Service control, manage the service. Volume controller, manage the hard drive and other thing. So all those controllers are controlled by the main controller called Cloud Control Manager. So it's worth understanding that node controller we do not directly discuss. We only discuss about Cloud Control Manager, and that is available in a meta plane or master plane. Internally, it delegates the request. Node related request go to node controller, route related request go to route controller, service related service and all. Now, what is route and what is service? I'll cover. But any questions so far? Okay, so route request means, like example, you have nodes here, right? You have different nodes. So you can say, let's say ABC. then you want to send route here. So that's called route. But let's say you send XYG and you want to send it here. That's the route. Route means based on your request, the request will go to particular set of machines. And that's the route. So example, if you are in a Michigan and if you request, it might come to Ohio. But if you're in California, if you request, it comes to that. So that is the route. Based on your request, based on your geolocations, based on the preferences, your request will be sent to particular local region. Same thing, route controller knows a pattern. Based on the pattern, it will route the request. So it's kind of very useful thing. Like sometimes you may need to have old version, new version, V1, V2, you can do that. So Kubernetes allows you to have a container with the application with version 1, container with application version 2, container with application version 3. So you can say that if V1 is there, all request goes here. V2 is there, all request goes here. If V3 is good, go this request here. So you can define those route pattern and route controller will interpret. I'll show you that in coming class as well. Now volume controller, whenever somebody say volume, think about hard drive. Basically, so the way what happens here is, so you can see here, you have a machine, right? And machine. So if one machine has its own hard drive, so this is what it try to do that. So for creating, attaching and mounting volume, interacting with the cloud provider to orchestrate the volume. Whenever they say volume, they're talking about hard drive, which is a persistent storage. PS, persistence storage. This part we discuss in a great detail. I'm hoping you're very clear. So pod is a group of container. It means one pod can have many container, you can say, and one pod can be part, multiple part can be part, one or multiple part can be part of machine. Docker is a container. Kubelet we call to agent that responsible for maintaining set of part. Kubelet and proxy route traffic to incoming request to the particular node from this service. So this is the proxy. If you don't have proxy, request will not be routed. So we'll talk about. We talk about the smallest unit of the work is pod. So pod is the smallest unit. We don't deploy container, we deploy pod. Pod are one or more container. We talk about that. So remember that. Now node is nothing but we talk about node is a machine, right? And it has, you have a kubelet, which is maintaining the pod, another kube proxy, which is nothing but routing the request to particular thing. Kubelet, we talk about agent that runs on each node. It makes sure the containers are running in a pod, and kubelet takes set in a pod specification. Specification is nothing but how many parts I need, what size of memory I need, what kind of CPU I need. Those are specification. I'll show you how to specify that. So that those taken care by kubelet. We talk about worker node, kubelet and all. So I'm not going to go here. And this is the overall flow happens. So you can say, users say, hey, I want to create a pod. API server will first write to the etcd. So that's the first step. Then it says, okay, I write that. And now it say watch. So the scheduler is watching new request. Scheduler say, okay, I need to create a pod. So it will write that information to etcd. And now kubelet is watching. So kubelet say, oh, etcd got something new. So let me start running Docker for. So kubelet will run the pod for you and then update the status. You might notice that every objects are talking to etcd. It's a very important aspect. If etcd is a central point for every information exchange, they are not talking to them directly. They're talking through that as a event process. So example, here, create pod API server, just write, and that's it. That's all it does. And then there's a watch by the scheduler. So it is when etcd is written, this is like a listening that, and then say, okay, I got something. Now you can ask a trigger. So that trigger part happen, and then it reads that, and then it start processing part. So scheduler is the one say, hey, now schedule this part per part. Now that information will go to Docker, which is the kubelet. Kubelet say, hey, I want to create the part. Depends on the specs you say, like how many use, it will create a part for you. And ultimately information will return to etcd. So a single point of time, etcd will have latest and greatest details. about what's going on with the request, what's going on with the infrastructure, what is the status of our pod, containers, and other things. Any question here?
Yeah, Tushar. There can be millions of nodes.
Sorry?
Right? Can you hear me?
Yeah, you were a little bit not audible. Now I can hear you. Please.
Okay. There can be millions of nodes controlled by control panel, right?
Yes.
So if what happen if control plane go down?
It doesn't go down because they are also
Duplicate.
many. They are
Okay.
scaling many, and they at CD also many. So they are distributed. So there are multi layers. It's not a single point of admin. There are multi layer of it.
Okay.
Okay. So again, let's repeat one more time. Cluster is a group of nodes. Clear? Node is a group of parts. Node is a group of parts. Cluster is a group of node. Clear? Pod has one or more container. Clear? One container has one applications. You can have more, but this is a basic block. If you are confused here, please ask questions. Any questions so far? Clear? Cluster
And
has a multiple.
yeah, this what is the environment in a particular node? Is it Linux or?
You can create your own environment. It comes from container. It comes from container. Remember last week we talked about we create an image and we say Linux, Windows, Mac applications. Part is it's a setup, but actually everything is inside container. So operating system can be Windows, can be Linux, can be Mac, can be anything. It comes with the image. Just like you remember EC2. In EC2, you use AMI, Amazon Machine Image, Windows, Ubuntu, Linux. Those are the image. It comes along with it. Part is just a place.
Okay.
Now, there are 5 essential things to understand. Now, this is very important aspect. Okay. It's much more important than so far what I explained. But before any question, before I proceed. Okay. So first of all, now namespace. So we talk about namespace. So in simpler way, namespace helps organizations working on or with a different project. So we talk about dev namespace, staging namespace inside the cluster. So your cluster, the cluster has a logical grouping with this. So namespace allows you much more organization and you can have parallel development without, stepping each other toes. Good thing. Yes, namespace is always used. And if it is smaller level, you do namespace. If it is a bigger level, you do cluster. Good. By default, you have default namespace. So when we studied, we did a kubectl get namespace and the default is there always. But along with that, there are 2 are deployed based on Kubernetes. So kube system namespace for object created by the system. And kube public namespace is reserved for cluster usage automatically. Make sense? So these 2 and this one will be always there for in your whenever you deploy like a Kubernetes in your Windows desktop. And you can switch the namespace. I'll show you. So why don't you go to your command prompt and type this thing, create namespace. You can create your dev namespace, create namespace prod, and you can say get namespace. So you can see that. So you can do one by one. You can just type and right click and paste. So you can run the command. So I'm saying here, kubectl, create namespace and give a name, dev, and press enter. So if you press enter, now you're creating a namespace dev. So you have namespace created. You can also use up arrow and you can say prod. So you're creating a namespace. So I have prod namespace. Now I can say get namespaces. So get namespaces. And you can see now my both namespaces which I created, I can see here prod and dev. Any questions so far? So it's, and you can also delete the namespace. So you can delete the namespace as I go, I can show you, but any easy command, right? The commands are pretty easy, creating namespace, but you should know what is namespace means, right? Otherwise the command is useless. So namespace is a logical grouping where you divide the cluster and how other teams work inside that namespace. Now let's continue. Now let's say you want to run namespace. So say launch Kubernetes object in a newly created namespace. So please understand, I have namespace created dev. Please pay attention. And I want to use ngx, which is nothing but a web server image. And that image, when I run the container, I want to give a name, this one. So this will be my container name. This is my image. If it is there in my machine, last week we were working, so I have it. If not, it will download it. And I'm saying when I download, that should run under dev namespace. So remember we created namespace dev and production. So I'm asking this namespace. You set the namespace, bring the ngx, create the part in this specific namespace. And when you do that, give a name like that. Once you do that, so let's do that. You copy, highlight, and copy this command. Right? Copy this command. And now you paste it anywhere, Windows or Linux, right? So I'm going to run, so you can see here, pod namespace demo. It's a pod namespace demo created. So it means this is my new container. It is created based on this image. It is created under dev. So you can see here, you can say kube get parts. So just do that. Parts means now I should have my ngx part, which I just created. So right now it's not finding that. Can anybody know why? Why it's not finding? I just created.
You didn't give the name of the part.
I don't have to give a name. I say parts, any parts, give me. Why it is not giving? I just created. You see that part is created. Shouldn't I get that?
But I think you have to be in.
Yeah.
You have to be in the namespace.
Exactly. So here I specify namespace dev, and here it is looking into default. So you will not find it. So I have to explicitly say that look for dev. So that's command. So I'll say, hey, got a parts namespace from dev. I can run this in a Windows also. You see that? Doesn't matter. So now you can see it's running. Clear? Any questions so far? So far, so good? Okay. I'm not getting any thumbs up, no question.
Yes. it's
So I'm
okay.
hoping that other people who are attending this class, I'm hoping you are understanding. If you have a question, please do ask. Otherwise, I'm not sure about your confusion part. Okay. Now, few more things we talk about. So you can see part and anywhere you have namespace. So you can see network namespace. That namespace allows you a logical grouping. Now, there will be a question people will ask you in interview. Listen carefully. When you are having a pod with a multiple container, like in this case here, that's not this one. Yeah, pod with multiple container, how the container will talk to each other, right? So when pod has multiple container, they don't go outside. They talk to each other just like through bridge network. So they talk to each other through bridge network. They don't go outside because they're in the same machine. So they talk to each other through bridge network. So as no communication between parts on the same node. So that happens through bridge network. So like how the bridge network works, you can maintain, because they are local, they are in same port, they are just knowing each other and they talk local intranet, but they don't go outside. So you cannot sense their traffic. But then the question is like an example, if I have, let's say in this situation, I have a node and I have part, which is this one, IP address 11, and I have part this one. So they both have a network namespace. So what happened? Each one has its own Ethernet. This is like a created based on Breeze network. So Breeze network creator interface allows this one, this is the IP address of this, and we call virtual Ethernet 1. So it has 1 and this one is 2. So when the request comes in using that table, which is called Breeze network, the request or traffic will be routed. Normally happens when you have two parts in the same machine. But it is also possible you have multiple machines. So example here, cluster, where you have two different nodes. And in that case, if you want to talk to each other, so you kind of create a routing table, just like, first where to go to request. So like based on that, it will go to node 1 or node 2. And then when you come to there, then it will again do bridge network. So you can do cluster network and then bridge network. So these are important things that sometimes they will ask how the communication happens. So here you maintain cluster. This is Kubernetes will maintain, and all those details where you see key value and all will be maintained in etcd. So all those like, which IP address, which node, etcd. Now, this is the interesting part of the day. Okay. Let me draw something so we'll understand. I need some help here, okay? Next 10-15 minutes, this is harder, but I want you to pay attention. So if you pay attention, you will learn something which most people lifetime don't understand. Ready? I need everyone thumbs up. Next 10-15 minutes. Thumbs up, or somehow you say you are awake. So 3, 4, 5.
Yes.
5, 6, 7. Good. Okay, this changed my life. Okay. You will not find that much detail anywhere in a proper way. So if you understand in interview, quite easy. So first understand, everything is a 3-tier architecture. 3-tier. So like that. You might have heard this 3-tier architecture like that. Now we have node like that. Now node has pod, and pod has a container, right? This is the what we have situation. And you have, let me use color here. So this is your container, right? So you are using container like that. And let's say you have container like that. So first question, if you are here, can you access this container? Answer is no. You cannot directly access that. So the interview people will ask you question. Container has application. Bank of America or Blue Cross Blue Shield, they all are running under container. So there is a applications, and you as a user, you are using your desktop browser and you type here Bank of America. Your request will come to load balancer. But then it will not know how to send the request here. It will not know. Because by default, container is not accessible. But if you are a development person, if you are a QA person, you can run proxy URL and you can get in. So proxy URL through you can get in if you're a developer. But external people cannot get in. So there are 3-4 questions people ask, and these are tough. Okay, it's simple, very simple. In 5-10 minutes you will understand, but questions are tough because majority people lifetime do not understand this thing, because they're more depend on, hey, I know container, I know how to run, how to distro. That's not enough. Architecture perspective, next 3-4 things which I explain is very important. So when you are having this, maybe let's say database, just an example, and maybe you might have a similar setup here where you have many pod, right? You have many pod, and inside pod you have many container running. This might be a business logic, maybe your service, web services here. And then maybe you have another pod, right? Where you have, so what happens? So this is called connections you have to establish. So the way Kubernetes does is very simple. container is not by default accessible. So you need to ask yourself question, if internal server, internal node, so this is the internal node, this is internal node. If internal node wants to talk to internal node like this, then there is a one strategy. Internal, if internal wants to talk, it's one strategy. Second is if you want to get from outside world, that's another strategy. So far so good. Now, if you, when you are accessing this thing, if you want proper load balancing means when you request here, sometime request goes here, sometime request goes here, sometime request goes here. So there is a third strategy. So you need to understand. If you don't understand, your application will fail more miserable. No one will know immediately. You will learn hard way. So how this strategy works? First, understand the small picture, and then we'll understand the big picture. Okay, I'm going to walk you through 4 or 5 things. Every step I'm going to stop. I have picture, we'll explain, and I'll also repeat next class also. But if you understand today, you will be able to do homework. So let's start with the first strategy. So let me show you the picture here. So here is the picture. Pod, see, we are not talking container because container is a minute detail. So these are multiple pod. If you want to do load balance, listen carefully. If you want to do load balance, so if anyone outside want to access your container, which is running here, your container, they can't access it. So Kubernetes say that you have to create a service. Remember one thing, you have to create a service unit, which is easy language, load balancer programmatically. Load balancer programmatically. And that service you can access. So you cannot access containers URL directly. So you can expose service. You can expose service. So customer can come and access service, and service will do load balancing. So question is, what is service? Yeah. So service is load balancer on top of pod. Service is load balancer top of pod. So because you have multiple pod, and if you want to do load balancer, you have to create service. So example, if I'm doing, let's say, please pay attention, it's very important topic. Okay, I don't ignore this. Let's say you have MySQL install, MySQL 1, MySQL 2 as a container, and then there is a pod. Now, if I have application here, I cannot use that. There is no way. If I try to use, I maybe have a point-to-point connection, which will not be auto scale. Remember what auto scale. Point to point will not auto scale because I tie. So what Azure said, Kubernetes say that you go independent layer called service, and service can allow, because you talk to service and service talk to this like that. So this layer, service layer, allows load balancing. So you can add anytime, you can remove anytime, and this allows you scalability. And service is not hard coding. Service go to etcd. Service go to etcd and say how many parts I have. And there is a concept called label. It will say, hey, for MySQL label, do you have any entry? Let's say I have 4. And then say, can you give me the detail? And this way service kind of discover, listen carefully, service discover the parts. It's no tight, it's not a point-to-point connections. Instead, it go to etcd and say, do you have a label called MySQL? Parts, it says say 4. Can you give me the detail of them? And this way service has. Now any application call, service already got that information at sea. So sometimes send request, sometime here, sometime here, sometime here. So service now allows you decouple between applications and the destination in our case, MySQL. So both can scale independent. Like example, if I have multiple level of application, they all will talk to service layer, and service is the Kubernetes component. So it is guaranteed scale. So service guaranteed scale, you don't write a single line of code for service. You just configure it through label. You write this one. You write this one. Service is a part of Kubernetes component, and you write this one. So you can scale this one. Kubernetes say, I will take care of service, and both can now decouple and scale independently. So this is one of the important aspect. Why do we need service? What is the purpose of service, and how do you configure? You configure through label. You configure through label. All containers should have a same label. If they are same, then route will go to their same. If you have another part, let's say you have MySQL here, just an example, MySQL, and here Oracle, then it will not send to Oracle because label will be different. But when you request come for Oracle, it will go here, it will not go here. So service discover its associated part through label. Question. Good. Now this is topic 1. Now topic 2, node part. Node part. So here, which we are saying is a cluster IP. So here cluster IP. This one is we are using strategy called cluster IP. So what is cluster? This is 1, 2, 3. And cluster IP means multiple IP. You have cluster and service does load balancing. So cluster IP, where we do like this thing. So this is we will learn this thing, but you can see here the concept here. So you will understand service. Okay, service. And then you are saying selector, which is the label, app, my app. So you are saying search my app and use the strategy cluster IP. Use the strategy cluster IP. It means you are saying there will be many and you will be doing load balancer cluster IP. Cluster IP normally used when you do load balancer at node level. Sorry, part level, my mistake, part level. Service has to be there because we talk about part. You cannot directly talk. If you talk, it's a point to point. So service talks to multiple part, you use cluster IP. Service talk to multiple part, you use cluster IP, which is normally you use it. But then there is another thing called node part. So let's see the picture first. Here, traffic comes, then proxy comes, then service comes, and traffic comes. Node part. So node part, what it does, it allows service, see traffic comes, listen carefully. Traffic comes and it can go directly to the part. So node port service that most primitive way to get external traffic to the service. So traffic comes, you don't need a proxy. Here you can see the previous one, you had a proxy. But if you are using node port, then you don't need a proxy. You don't need a proxy. You are exposing static port. You're exposing static port. So now request will come here, then it will go here, and then things will happen. This one, external traffic for primitive. Primitive means debugging perspective or QA perspective. If you want to debug or QA, then you use. It is not recommended. It is not recommended. This is not recommended for production version, but for developer perspective, for admin perspective, if you want to debug, you can. What's the difference? Node port allows you to connect to the particular node with the port configurations. So how do you configure? Same concept, same service. Here you just write node port. That means you are now exposing a particular port where external traffic will come and then it will route to the particular node. This is basic. The another one is called load balancer, which is kind of good. Now, load balancer is, you can see here, service is same service, but here load balancer means you have bunch of services. And services are also pointing to bunch of part. So here service 1, your service 2, your service 3. So service 3, each one has its part. So now load balancer will send request here and here. So multi-level of routing happen. So now you can scale much better. So if you add a load balancer, you see service was a load balancer at part level. Please understand. Service was load balancer at part level. But if you want service level also load balancer, then you need a load balancer on the middle. So now you can have bunch of services. So if one service goes down, you can still survive. And this is mostly in industry people start using. So part level, service load balancer, service level load balancer. So this is very popular. So it's a very standard way to expose service to internet. Questions? questions. Okay. Now let's go to this one. So you will understand the real S1. So this is what most of company use, Ingress. So this will be a question, what is Ingress? So Ingress is a global load balancer where you send the traffic and you control the routing rule. Routing rules means if route comes from here, then it goes to this service. If route came from here, it go to this service. If Ingress itself is nothing but global load balancer, which is we just discussed few minutes above. Multiple services you are providing load balancer through Ingress, and multiple part you are giving load balancer through service layer. So these are traffic cannot directly go to part. That's the period. You have only two choices. Either you use Ingress or you use node port. If you do node port, you are hard coding, which is not good. So now you have three approach. One is a cluster IP, please pay attention. Second is called node port. And third is the Ingress. How all things work together. So if you see this diagram, you will understand. So let's assume outside world, there is no question, Ingress. Outside world, always Ingress. So Ingress is pretty easy. If you are using Amazon.com, you are using Ingress. If you are using Google, you are using Ingress. If you are using Facebook or Netflix, you are using Ingress. Why? Because external people always go through Ingress. So that part is clear. Then I'm very confused with the cluster IP and node port. I can solve you the solution. If you have, listen carefully, if you have multiple part and you want to give a load balance, these are identical. Multiple part, identical, then you can use service cluster IP. So cluster IP is multiple part identical, and you want to provide load balancer. So that's part. Now node port is a very special thing. So let me explain. There are two purposes of node port. So if like say this is available here, right? And this is available here. And now this is node 1 and this is node 2. And I want connection this way, node to node connection, node part. Or I want somebody directly come here without service, without load balancer, without performance, anything, then node part. Node port allows me to directly go to the particular node. So I can have one node to another node, point-to-point connection. I can do that. This will not be exposed. But if I do node port from here, then the proxy layer through, I can talk to part and part through container. So node port allows debugging aspect also. So you have to use appropriate in order to create the diagram. So whenever you do diagram, please understand, always increase first. The second level will be always service layer. Try to use service layer. So service layer you always use. When you use service layer, when you have identical part. But let's say you have in between something like that, like example, I'll draw the picture so you'll understand. I have container 1 and container 2. These container, they are identical, I'll use service. But if they are not identical, but this, let's say this is container 1, container 2, and I have similar setup, container 1, container 2, they are, this container 1 and 1 identical, this container 2 and this identical, then service level still allow us. So service level allow us when you have load balancer at part level. So you have to think about it. But if you want load balancer at node level, listen carefully, node level. So this example. So here is the situation. Cluster IP, you got the proxy and service level. So part level load balancer, and here you use service cluster IP. But load balancer, you're not going through proxy, you're going through load balancer, which is, this is nothing but Ingress. This is Ingress. Now, if you see here, if you directly want to go to VM, please pay attention. VM is nothing but node. So if you want node level load balancing, then node port. Name itself says node level load balancing. This one, pod level load balancing. This one, service layer load balancing. So please understand, this is very, very important for interview and your architecture perspective. Service layer, like this box, if I repeat this box multiple times, and if I want service layer load balancing, then ingress is the way to go. Service level ingress, which is the first layer where customer interact. The node level, then like example, you have, let's assume you have application server, just an example, application server, and you install MySQL. You install MySQL. You did not install, listen carefully, you did not install container. You have machine where you install MySQL. Your machine, you install MySQL, then it's the node part because you're not using container, you're using machine. So machine level, node part. So that's one strategy. Service part level, that's a cluster IP. And service layer is a load balancer or ingress. Any question? You will be asked guaranteed this question in interview. Because if you know this, then you can use Kubernetes, otherwise useless. Because entire architecture setup happen through this one. And all those setups you are going to do through configuration file. This configuration file. You will always question yourself, what is this node port? You will always question, what is this cluster IP? If you do not understand what I explained, then this will not make sense to you. It means you are just doing random. There's no point, right? I can do the entire application development this if I know this concept in less than 10 minutes because I know what I'm doing. So here you can see they're using ingress. So I know that definitely there will be a services. So here they use ingress. So if I come here, they have 7 backend, right? And then there's a rule. If I this, then send here. If it's this, send here. So definitely they are using a service layer. So ingress is load balancer at service level, and they're sending the services. So you can see here service name, other, and service port, and the service name. So they are doing load balancer at service level. Everything in a Kubernetes is connected through label, such kind of label. And this entire file, which you see here, is YAML file, which we'll cover next class. So next class we'll create this YAML file and all. You have some homework to do. I know we are about time, so some homework. Please go through this and
Yeah, a quick question.
Yes, 1 second. Let me complete this thing. So homework. This is your homework. Make sure you go through homework. I need 100% homework. If I don't see 100% homework, the next class will be tough. Because unless you know the basic thing, you can't do the practical thing. It won't take time because same thing we explain here. I'll put the recording also.